All right, so here we go. So here's another example of a piecewise function, and this time they want us to graph it, okay? So again, we're looking at the intervals, right? So this is, the interval is hinged on 1, right? So this is the rule when x is less than 1. Here's the rule. And then when x is greater than or equal to 1, this is the rule. So first, let's consider this rule for x less than 1. So everything that's less than 1, we're going to use 3x, negative 3 times x. So now, so that means let's just use the integers and plot this thing. So at 0, it's going to be 0, right? When x is 0, it's 0. When x is negative 1, it's going to be 3. Right? So we've got a straight line. It's a linear function. And we've got a straight line. And so it's got a slope of negative 3. So in this case here, we're going to go down 3 and over 1. 1, 2, 3, and then over 1. So that's going to go right to here. But it's less than 1. So what's going to happen is we're going to have a point here, but it's going to be an open circle. Right? So what that means is it's going to go down all the way. So that's how the first one. So for negative 3x, for everything that's less than 1, it's going to have an arrow going up this way, but it's going to go all the way down until you get to 1, and it's going to be an open circle because it's less than. So it does not include the value of the function at x equals 1. Now, what happens at 1? Well, now it changes this rule, which is negative 3. So at 1, it's going to be negative 3, which is right here, which we're going to fill in the circle. It's just going to be a dot, so a filled in circle. And now it's a constant function, so from everything greater than or equal to 1, it's going to be a horizontal line. And so that is the graph of this piecewise function. Now notice that there's a gap here, okay? So it's broken, there's a gap, it jumps, right? From here to here, okay? This is what we call a discontinuous function. So what that means informally, it means that we cannot draw this graph with a marker or a pencil without lifting the pencil off the paper or off the board. So anytime that we cannot do that, it's discontinuous. And so in other words, a continuous function is a function where we could draw the graph of the function without ever lifting our pencil off the paper. Now that's the informal definition. The formal definition is learned in calculus, okay? But informally, just remember continuous functions. We can draw the graph of a continuous function without ever lifting our pencil or pen or marker off the board or paper. A discontinuous function is where we would have to, where we can't do that, right? All right, that's it. So we'll come back with another example.